Hey guys, welcome back to my channel. From yesterday's video, we learned a little bit about the ARP protocol and we saw how the layer 2 forwarding happens, and we saw how the packet which is trying to communicate from host A to host B has reached the router A. Okay, so today we're going to talk a little more about how the routing happens, and we're going to see how the packet gets encapsulated with the other headers now, and how the routing table gets populated. Okay, so this is the router A. Now we know that the packet has reached router A. It's with data, it has L3 header, it has L2 header, right? So router A will see that the L2 header, it will strip the L2 header and it will see that it is destined for itself. Okay, then it will check the layer 3 header, it will check the destination IP, it will see that the destination IP is that of the host D, right? So let's say host D has an IP address of 22.22.22.2. Okay, that will be the IP which will be there as a destination IP in the L3 header of the packet. Now what happens is in the router A, let me write the router is A, uh, routing table. Okay, this is the routing table. So as soon as we configure the two interfaces, right, on the router A, one which is going towards the network 11.11.11 and the other one which is going toward 22. Let me provide this as interface 1 and interface 2. As soon as you configure interface 1 and interface 2 with an IP address, what will happen is it will automatically populate the routing table with that particular network. Okay, so it will say that for 11.11.11.0/24 use interface 1, for 22.22.22.0/24 it has to use the interface on interface 2, or it will say that for this network you have to use this particular interface for the next hop. So router A knows that to go to um, host D it has to go out of the interface 2. Okay, that's what we got to know so far, right? Since these two are directly connected, so it will go out of that interface and the packet will be received by host D. So the packet, it will see that now again what happens is, right, it has to encapsulate the layer 2 header. It knows its own layer 2 header. It will populate its own layer 2 header. Now it does not know the MAC address of host D. So again what will happen is, ARP resolution protocol will be run over here in this network 22.22.22.0. There is no switch over here, so what happens is ARP request is sent to one out of one interface. It goes to host D. Host D sees that this is intended for this particular device, then ARP reply will be sent back and router A will populate. Now router A will populate 22.22.22.2 as let's say this is MAC address is DD. Okay, it will say it's DD. So now in this packet it will put the new header with the destination MAC address of host D, which is DD, and the source MAC address will be of itself, which will be FF, and the packet will be forwarded. Uh, the packet will be then forwarded to the host D. So the message is now the message sending is now complete from host A to host D, right? So we saw that over here again the ARP protocol runs and the reply and request happens. So they both get to know the MAC addresses of each other. When the ARP request is sent to host D will populate its ARP table. When the host ARP replies sent back from host D, the router A will populate its ARP table. Okay, and then it will use that MAC address which it has received, which has got to know now in the L2 header, and it will forward the packet to host D. Okay, now this packet is reached to host D. Now let's say, just for an example, right, let me just remove this now. I hope this made sense. Okay, let me remove this, and let's say okay, Let's say I have this was what, dot 1, 22, 22, 22 network. This is dot 1, right? It's connected to one more router, and then it's connected to host D, right? And let's say this is 22, 22, 22.2, and this is 33, 33, 33.1, and the IP of D is 33.33.33.2. Okay, so this belongs to 33.33.33.0/24 network. Now, how does the routing take place over here? Right, as we know that on the router A, what we'll have to do is we'll have to configure a static route, saying that to reach. So now the destination IP will be the IP of host D, which is 33 network. So on the router A, we'll have to configure a static route saying that, in order to reach the 33.33.33.0/24 network, go out of the interface 2. Okay, that will be a static route which we will configure. As a network engineer, this is what the network engineer would do. So once he does that, the packet will be forwarded to router B. Let's say this is router B. Okay, and then on the router B, it will again do a routing lookup. Then it will see that it has the 33.33.33.2. So this is basically the 33.33.0/24 network, which belongs to this particular interface. And as it is directly connected, this will be automatically populated in the routing table once this is configured. As I told you about this, right? It's a directly connected interface. As soon as you configure it, it will automatically populate it on its routing table. So router B also has this information now, and it will then send the device again. Same way ARP resolution will happen, and it will get each other's MAC address, and then it will update the MAC address, and it will send the packet out to host D. This is how host D will also receive the information. So first the ARP resolution happens, then it will look up its routing table, it will have the routing destination IP, it will have the source IP, it will have the destination MAC, it will have the source MAC address. So once you have all these 4 things, then it can forward the packet out. So like this, the packet will reach host D. Alright. Now let's say if I don't want to configure a static route, right? On the internet now we have many devices, many routers in between two hosts. Then what happens? So to not every you as a network engineer, I cannot go and configure every single router with a static route, right? I need to have a lot more control by just letting the protocols do its thing. So that's why we have routing protocols like border gateway protocol, like BGP, OSPF, ISIS. So all these protocols are running on the internet, which by certain rules and certain standards which have been predefined. They populate each and every router's routing table based on certain rules. Now we'll learn about each of these protocols, what kind of algorithm they use to populate, what kind of routes. Like there will be multiple routes to reach a particular host, right? You don't have only one path, you have multiple paths. Now it will do its own algorithm calculations, it will follow certain rules to choose which is the best path, and it will use that path to populate in its routing table. So we'll learn about that in the next coming videos. So I hope you understood a little bit about how routing takes place with static route and default route, and this is how a packet would traverse from host A to host D. Do let me know if you have any questions. Please like, share and subscribe. Thank you.